Hi, this is Mr. Bennett. Here we go again. This is video 1-2. We're going to talk about dimensional analysis today. Now, it sounds kind of scary, but when we get down to it, what you will see is dimensional analysis should help you with those conversions that we were doing the other day, the metric system or SI unit system conversions. Some of you were struggling with how to set up the proper conversion, had questions about the way that I set up the problem, how I used the line and I put the one type of units on the bottom and the other type of units on the bottom, or on the top rather. That comes from this idea of dimensional analysis. So after today, those problems should be a piece of cake if you understand how this works. Second thing I want to mention about this video, this is probably one of the most important videos that you're going to watch all year long. So you'll probably come back to this video several times throughout the year just to freshen up. But dimensional analysis, if there's one video that you watch and you learn and you understand from start to finish, this is it. All right, so here we go. Okay, so we're going to get into dimensional analysis. Dimensional analysis is really a tool for converting from one unit to another. Sounds scary, but again, it's just a tool and it helps you to go from one unit to another. In order to do that, you need something called an equality. An equality is really just something that shows the relationship between two terms. It shows how two units are equal. So I'll give you an example. 12 inches equals 1 foot. We know that equality. As Americans, that's one of the equalities that we typically know. 12 inches equals a foot. Right. Now, we talked about yesterday, or in the previous video, that we don't use inches and feet, we use SI units in science. So the equalities that we need to know are different. And what I've done here is I have actually written 3 equalities that you need to know. Memorize these, catalog them away. I know memorizing is rough, but there's 3 of them. You need to know, we've talked about 2 of them already, you need to know that 1 kilo is equal to 1,000 base units. Remember, base units can be anything like a gram, a liter, a meter, etc. And a base unit is equal to 1,000 milli-units, whatever they may be, millimeters, milligrams, milliliters. The third one you need to know is that 1 centimeter cubed, this was a unit we briefly mentioned in terms, it's a way of measuring volume, is equal to 1 milliliter. Okay, these are equivalent. So 1 centimeter cubed of, specifically this actually is referring to water. If you really want to get technical, this is really only 100% true for water, but generally speaking, we can say that 1 centimeter cubed is equal to 1 milliliter. So that's dimensional analysis in a nutshell, what it does. It's a tool. Now we need to talk about the rules. There are rules for dimensional analysis, and there are 5 of them. So what I suggest right now, pause the video. Pause it, go through this, fill in your guided notes for these 5 rules, and then listen and make any other notes or little extra things that you want to add based on how I explain it. So if you haven't paused it and filled in your guided notes yet, pause it right now. Okay, so let's go through these rules. Rule number 1, all numbers are written as fractions. Okay, all numbers are written as fractions. What that means is if I give you an equality, and the equality is something like, well, let's say if you're dealing with kilograms, okay, and you're having to go to grams, we know that 1 kilo is equal to 1,000 base units, or 1 kilogram is equal to 1,000 grams. So when we're doing dimensional analysis, this would be written as a fraction. That means it would get written this way. What we will see is that you can actually write this equality. You can express it either this way with kilograms on top, 1,000 grams on the bottom, or you can write it like this. You can flip it. It doesn't matter because equalities really are just 1, because 1,000 grams is the same thing as 1 kilogram. This is really just 1, and this is really just 1. But we express it as a fraction, and you can flip it whichever way you need to solve the problem. Now, number 2, write everything with its unit. I mentioned this in the previous video. No naked numbers. In other words, if I give you 1,000 grams and you are, filling in your formula and setting up your dimensional analysis, make sure that you always include the units. Do not, in the middle of your calculation, just write 1,000 and not have the unit here. The units need to be here. No naked numbers. Rule number three, arrange conversion factors so the previous unit cancels. We call this diagonal units. Let me show you what I mean. Let's say that we had 44 kilograms, okay? And we want to go to grams, all right? We want to know how many grams we have. Well, I need the equality to solve this. I need the equality between kilograms and grams. That means we're going to go up here to these guys. And it turns out, since I am starting with kilograms, I want to use this one right here. So what I'm going to do is I'm going to rewrite that right here. So 1,000 grams over 1 kilogram. I have arranged the conversion factor. That's what this really is. An equality written as a fraction is called a conversion factor. I have arranged it so that the previous unit, which in this case is a kilogram, is going to cancel. How is it going to cancel? Well, we have kilograms on the top and we have kilograms on the bottom. So when I take a kilogram and I divide it by a kilogram, anything divided by itself cancels out. So now in our problem, our kilograms are gone. The only units we have left are grams. So it's going to be 44 times 1,000 divided by 1 grams. So that means we have 44,000 grams. Okay. Now, the last two rules, we don't really need to demonstrate too much. Basically, it just means if the numbers are on top, like up here, okay, you multiply them. And if a number is on the bottom, like right here, it gets divided. Okay, which makes sense. It's underneath the line, you divide. If it's above the line, you multiply. Cool. Those are the 5 rules. Now, we just mentioned conversion factors. Just to be clear, to convert from one unit to another, you need an equality. We've already talked about equalities. We know what that is. It shows you how one unit is equal to another unit. When you write an equality as a fraction, it is called a conversion factor. So, for example, I think we use let's use a different one. Let's use the 1 centimeter cubed equals 1 milliliter. Now, this is kind of a weird equality because it's 1 to 1. So generally you can do this math in your head, but by setting up this proper conversion factor, it's going to make sure that you have the right units in your answer. And if you want full credit for an answer, you got to have the right units. So if we were to take this equality and rewrite it as a conversion factor, what we would do is we would simply take one of the units, in this case 1 centimeter cubed, and we would put it over the other unit, so 1 milliliter. We could also write it the other way, so we could put milliliters on top and centimeters cubed on the bottom. The way you determine whether to put centimeters cubed on top or milliliters on top goes back to this rule back here where we said that we arrange it so the units cancel. Right? We arrange it so the units cancel. So you want that diagonal setup so that centimeters cubed is diagonal to the units that it needs to cancel, or milliliters. All right, so conversion setup. Let's take a look at it. This is what I'm talking about actually right now. So if done properly, the old units cancel, giving you the amount in the new units. So let's do an example really quick. Let's say that we have 10 cubic centimeters of water. Okay. And we just said that the conversion factor, right, or let's start with the equality, 1 centimeter cubed equals 1 milliliter. We just talked about that, right? So when I set up my conversion, I'm going to first of all put a dot and a line, okay, because I'm multiplying, and then I put a line. That's how these dimensional analysis problems always start off, with a dot and a line. Okay, I have my equality that I know is going to get me from centimeters cubed to milliliters, and let's just say that there's a question that says you have 10 centimeters cubed equals blank milliliters. Okay, that's our question. So we know we have to go to milliliters. So what we're going to do is we're going to take these equalities, set up a fraction or a conversion factor that will cancel out our centimeters cubed and leave us with milliliters. So that tells me that my centimeters cubed must be on the bottom. Have to be down here. Why? Because centimeters cubed needs to be divided by centimeters cubed to get rid of it. On the top of the line up here, I'm going to have the other half of the equality. So 1 milliliter will go up here. So I'm left with 10 times 1 milliliter divided by 1 gives me 10 milliliters of H2O. Okay, so the key is you need the equality. You need to know how to get there by relating the different units. But setting up this fraction is all about looking at the unit that you're starting with and putting the unit, the matching unit, on the bottom. The unit that you want goes on top. So the way I remember this is you always have your given dot line. By given, I mean it's the number that we were given initially in the problem. Okay, you always have a dot and a line, and then these are the units you have, and these are the units you want. So if we look up here, given was centimeters cubed. Those are the units we have as well, so they go on the bottom, and then the units we want go on top. If you set it up correctly, the old units will cancel out, giving you new units.